Hey folks, welcome back to part 3. We've been talking about molecular geometry, shapes, electron geometry, and in this final part we're going to work through some examples together. All right, here is practice exercise 4.1 from the textbook, and there are 6 examples here that we can do. So given Lewis structures here, right, determine electron geometry, molecular geometry, and molecular bond angles. Okay, so the first one, CH3Br, okay, has this Lewis structure. And so the electron geometry, right? All we need to know for this is the number of bonding groups. So how many bonding groups are there? There's 4 around the central atom, right? So that gives us tetrahedral. Now the shape or molecular geometry, right? All 4 of these groups are bonding groups. So the shape is also tetrahedral, which means the angle must be 109.45 or 0.5 degrees. Okay, the next one is NF3. And the Lewis structures are given, but it's still good to draw them out for ourselves for practice. Okay, there's NF3. So the electron geometry. How many electron groups are around the central nitrogen? 4, right? So once again, tetrahedral electron geometry. Now the shape, what do we have? We have 3 bonding, 1 non-bonding, so that would be trigonal pyramidal. And the angle would be the tetrahedral angle of 109.5. The next one given was OF2. So we have an oxygen bonded to 2 F atoms. All right. So electron geometry, once again. 1, 2, 3, 4. Tetrahedral. How many, well, shape. How many of these 4 groups are bonding? 2. So that means that the shape would be bent. Like that. And the angle is the tetrahedral electron geometry angle of 109.5. The next was COCl2. Lewis structure given as CO double bond and CCl single bonds. Right? Electron geometry is based on the number of electron groups. 1, 2, 3. So we've moved on, and we now have trigonal planar. So the shape, all three groups are bonding groups, 0 non-bonding groups. So the shape is also trigonal planar. And this is actually not drawn correctly here, right? Lewis structures just puts things at 90-degree angles. Really, it should be like this, all in a plane, which means the angles are 120 degrees. The next is SO2. So these are some of the examples that we did together already. This is a sulfur, the lone pair, 2 double bonds to oxygen, each with 2 lone pairs. So how many electron groups? 1, 2, 3. The electron geometry would be trigonal planar. The shape, well, we have 3 electron groups, 2 bonding, 1 non-bonding, so bent. Like this. And the angle is 120 degrees. All right, last one. HCN. Here we have carbon and nitrogen with a triple bond, and carbon with a single bond to hydrogen. All right, the electron geometry based on the electron groups, 1, 2. So linear. And the shape must be linear. So this is actually drawn correctly. It's the only one that we can draw where the Lewis structure is actually the same as the shape structure. And the angle is a straight line of 180 degrees. Okay, here's a few multiple choice questions. Select the correct electron geometry and molecular geometry for formaldehyde. Pause it and try this for yourself. Okay, and we're back. And the answer is D, trigonal planar electron geometry, trigonal planar molecular geometry. Okay, same molecule. What bond angles are present? Well, it's definitely not 90 degrees. It looks like it in the Lewis structure, but we know Lewis structures are not always correct in the actual shape like that. So it's trigonal planar, right? So trigonal planar means 120 degrees. We just did this one. Hopefully you got it. Select the correct electron geometry and molecular geometry for hydrogen cyanide. All right. Yeah, we know that one. Linear and angle, 180 degrees. All right, final thoughts on molecules that have more than one central atom. Larger molecules can simply be thought of as containing multiple central atoms. So the overall shape is described as a series of shapes around each atom center. For example, methanol, which is the one that makes you go blind, by the way, has carbon and oxygen both as central atoms. And so we can describe the shape around each one. Right? So see how carbon has 4 electron groups. All 4 are bonding, so it would be tetrahedral around the carbon. And the oxygen also has 4 groups, but only 2 bonding, and so that would be bent. And we can see that here in the ball and stick model. Here's CH3, propane, and each carbon has 4 bonds, and so each carbon is tetrahedral. All right, so that wraps up the first section, all about shapes and geometries. So again, the best thing to do is to get a model kit and hold them in your hand. If you'd like, I can get you some parts. And there are also some good websites that show 3-dimensional shapes that you can turn around and manipulate on the screen. So until next time, take care and see you then.